Hello, everyone. My name is Mr. Lee, and welcome back to As Quickly as Possible, a series where we discuss math and science topics as quickly as possible so that you can get done with your homework as quickly as possible. I wanted to go ahead and take a little break from the trigonometry series because honestly, there's a bit more that I got to brush up on myself before I feel comfortable in teaching higher topics in that regard. So I decided I wanted to go ahead and delve into another topic and kind of cover my base there. So today we're going to be talking about exponents and the inverse of exponents called logarithms. Before we delve into logarithms, though, I did want to jump into an example problem real quick so that we can actually, hit the bottom and just kind of catch up and remind ourselves on how exponents work. So when a caterpillar larvae hatches, it weighs only 10 to the negative 2 grams. However, each day it is able to eat 10 to the 4 times its body weight. How many grams of food can the larvae eat each day? And I actually stole this question verbatim shamelessly from ck12.org. You can find that problem there if you just look this up similarly. You'll find a video on how to solve it. But I felt that this is a great example and, is too good to not steal. So, anyways, we're given three parts to this problem right here. We're given the 10 to the negative 2 grams. We're given the 10 to the 4 times its body weight. And then we're given, well, we're not exactly given, but we're given something to solve for, which is how many grams of food can the larvae eat per day. So that's like three parts to the problem. So we got this right here, 10 to the negative 2 grams. And then we got 10 to the 4. And then we have how many grams? We're going to make that x. So the indicator on what to do, what operation we're going to use right here, it's a pretty big hint. It's times right here. So we're going to go ahead and run that right there. So times its body weight, and this is its body weight right here. So basically we're doing 10 to the negative 2 times 10 to the 4 equals our x. Now, the thing about exponents, when you're multiplying them together and you have the same base, so these exponents have the same base as 10. When they have the same base, essentially all you need to do is add the exponents together and it will create one exponent that you can solve for. So 10 to the negative 2 times 10 to the fourth power, that will be exactly like saying 10 to the negative 2 plus 4 equals x. And of course, if we simplify negative 2 plus 4, we get 10 squared equals x. And we all know that x squared equals 100. That means that the caterpillar will eat 100 grams of food per day. Now, here's a second word problem that I wrote up based on the first problem that we just did. And we're not going to work on this yet. I do want to read it so that we can get a good idea on what exactly we're working with when it comes to logarithms. But we're not going to go ahead and jump into this. We're going to jump into a few other problems, smaller problems, before we actually delve into this one, which I'm deeming the most difficult out of the set that I'm proposing right now. So the problem reads, when a caterpillar larvae hatches, it weighs only 10 to the negative 2 grams. However, each day it is able to eat 100 grams, which is 10 to the x power times its body weight. What is x? So basically, if we use the same logic that we did in the last problem, it's going to look a little bit like this. So 10 to the negative 2 power, that's not a plus, sorry, that's a multiply, times 10 to the x power equals 100. So this is what we're going to come back to solve. There are a few problems, like I said, that we're going to solve before this, but we will come back to this. All right, so here are the example problems that I want us to go over before we get to that big word problem. And we can start with number one, which is 2 to the x power equals 16. So 2 to what power equals 16? Now, you might be able to run this in your head real quick, and I applaud you for that, but it is important that we understand this process because it's going to get a whole lot more complicated once you actually start applying logarithms in algebra. So, before we break this down, we need to identify which parts these are called. So, we got the 2 right here, which we're going to call the base. We're going to take this x right here. We're going to call that the exponent. And we're going to call this right here, the 16, we're going to call that the constant. So let's say we wrote the base as y, and we wrote the exponent as x, and we wrote the constant as z right here. So this is basically, this is its bare bone version right here. So how we would do that with logarithms is that we would take log, and then we would take the base right here and we would put it as like a little subscript right after the logarithm. We'd put a little subscript right there. And then we take the constant over to the right, which is z, and we do z equals the exponent, so x. So logarithm y, z equals x. So we can go ahead and plug in for this and go ahead and solve for the problem. So we got the base, that's what we're going to start with. So log base 2 times the constant right here. So that's the function. This is the function, log base 2, and this is what's being plugged into the function right here, the 16, is going to equal our x. Now, quickly before we solve for this, if you look at your calculator, you will find log by itself without really any base pair. Do not type in just log and then type in 16. You need to push the second button or the shift button, depending on whether you're using a TI-84 or a Casio. And you need to, it'll basically, most of the time, it'll look like this. It'll say log, and then there'll be a little black square right there. And when you push that, it'll let you fill in for the subscript right there. And once you fill in for that, you're just going to put 2. All right, so once you plug this into your calculator right here, you should get x equals 4. So if we take 2 right here, if we plug it in, we take 2 to the 4 power. That means we have 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 right here is also 4. And 4 times 4 equals 16. And we look at that, yep, we got 16 right there. So therefore, x does equal 4, and we've got the correct answer right here. All right, now let's move down to number 2. So we got 3 to the x power equals 27. So let's write this out exactly how we wrote out the last one in logarithms. So we take log, and then we take our base right here, which is 3, and we do log sub 3. And then we take our constant over to the right, which is the solution to 3 to the x power, and we take 27, and then that will give us our x. Now, if you run this through a calculator, you will get 3. So if we plug this in, we take 3 to the third power equals 27. All right. Now you take 3 times 3 times 3, you get 3 times 3, you get 9. 9 times 3 equals 27. Yep, that all checks out. Therefore, we've got number 2 correct. X equals 3. Now, number 3 right here is a little bit trickier. If you look at this, you get log 10 million, but we don't have a base right here. We don't have anything right there to represent our base. So if we were to write this in exponential form, what would it look like? So it is worth noting that whenever you see a logarithm without a base, or seemingly without a base, that means that the base is actually 10. That's because logarithms are used a lot in scientific notation. Therefore, it would be a little silly if you wasted your time, writing 10 all the time whenever you were working with your logarithms within whatever science topic you're working on. Therefore, what the problem is really saying, it's saying log base 10, 10 million equals x. Or we could write this as 10 to what power equals 10 million? And whenever you got a number like this, just with all these zeros and you got 10, basically all you have to do is count the zeros to solve for this problem. So x equals 7. So that means if you take 10 to the 7th power, it will equal 10 million. So very important thing to remember before we move on is that whenever you don't see a base in logarithms, it's just log, then that means that the base is going to be 10. Now we can move on to question 4 right here. So we've got 1/2 to the x power equals 1/4. And then when we write this down in logarithms, we'll do it like this. We got log base 1/2 1/4 equals our x. Now, if you plug this into a calculator, you are going to get the number 2. So let's plug that in and check. So 1/2 squared equals 1/4, right? So let's take 1/2 times 1/2. And if you remember how to multiply with fractions, we basically just multiply straight across the numerator and the denominator, pretty much no matter what it is. So we can just do this. So 1 times 1 equals 1. 2 times 2 equals 4. And that gives us an answer of 1/4. And if we look right here to our answer to the problem, we have 1/4 here so that we know that x does equal 2 and that this works. And then finally, we got this problem right here. So let's go ahead and let's blow it up a little bit. God, my pen is not working. Hold on. Let me go get a new one real quick. All right. Hopefully this one's a winner. Seems like it's the best we're going to do. So I'll try my best. X 27 equals 3. All right, so now we've got something a little different. We've got the base that's a variable within this logarithm problem, and we basically just have the variable over here. So whenever you see something like that, it is worth noting that you can also just revert it back into exponential form and see if it makes more sense that way. So we take the base right here, right? And then we take our answer right here, which is 3. So x cubed will equal 27. So now we got the problem like this. So now we can actually solve for the problem once it's written out like this, because all we need to do is take the cube root of both sides. Remember algebra, what you do to one side, you have to do to the other. And once you do this, you should get x equals 3. And if you also remember, this is very reminiscent to problem number 2 right here. So yeah, let's go ahead and move on to that big problem now and see if we can tackle it. All right, so now we're back here again to the big problem that I said that we would leave for last, because it is, you do kind of have to work around some algebra a little bit. So the problem reads again, once more, when a caterpillar larvae hatches, it weighs only 10 to the negative 2 grams. However, each day it is able to eat 100 grams, which is 10 to the x times its body weight. What is x? All right, so let's write this down again. We've got 10 to the negative 2 times 10 to the x, that's our variable, we don't know, equals 100. So now what we want to do from here is simple algebra. We need to separate this. We need to separate the variable from this exponent right here, and we just need to basically put it on that side. So we get 10 to the negative 2 divided by 10 to the negative 2, right? And then we get 10 to the x power, and you should get a number that's 10,000. And now once we have it written in this form, we can actually write it down as a logarithm. So we take this, we take log, and then if you remember from the previous problem that we went over, if the base is 10, you don't have to write anything on logarithm. So you don't have to write like log 10 or anything. You can just leave it blank. And 10 is the only number that works for, and Euler's number 2, but we're not going to be talking about that right now. So log, and then we got our answer. So log 10,000 equals x. I wrote that kind of funny. Hold on, let me try again. There we go. That looks much better. Okay, so once you get log 10,000, once you plug that into a calculator, your answer should be 4. So let's plug that in. Let's make sure it works. So 10 to the negative 2 times 10 to the fourth power. Remember, we're plugging in for 4 to make sure that this is working, equals 100. All right. And if you remember from the previous problem, we can basically just sum it up like this, plus 4. So 10 to the negative 2 plus 4 equals 100, which simplifies down to 10 squared equals 100. And if you take 10 squared, obviously you get the answer of 100. Therefore, once we plug 4 into the x column right here, then that means that it works. This logarithm, this algebra that we did, all checks out. And it's always important to plug in for your variable so that you know that you're for certain that you're getting the right answer. All right, and that just about wraps up our topic on logarithms. I'll probably have more videos on this with more complex problems regarding logarithms. So, yeah, take it easy, guys. I hope you learned something and have a good day.